as I mentioned, Nvidia GTC is happening right now. And GTC is probably the biggest industry event out there. So, Al, let's take a few minutes to look at what's being announced. Now, I do have to admit, now GTC is going on live on Tuesday, Wednesday, etc. You know, the keynotes. We're actually recording this Tuesday afternoon Eastern time, which means that the keynotes have just wrapped up. And we've been watching and we've been following remotely and we're talking internally and we're trying to keep up to date on what's going on. Um, Al, at the risk of being entirely outdated by the time this gets published, what's your take on GTC generally and the keynotes so far?
Well, I think the core of what we see from GTC is a fairly standard. Things are newer, faster, bigger, better elements. And we expect that. We expect that the engineers who are designing these chips, these systems, have been working really hard to make them more efficient and deliver more for their customers and deliver larger systems, because trying to scale to thousands and thousands of servers with tens of thousands of GPUs, that gets to be challenging. So trying to consolidate that footprint is a significant element here. Interestingly, seeing this shift from a biennial to annual release cycle. I'm not sure whether it's the biennial that means every 6 months or the biennial that means every 2 years. I just love the English language for being so random about that. Definitely seeing more chips being released or newer chips being released. Some thoughts around doing inference at the edge out there from Nvidia as well, because lots of data generated at the edge, and this is where we need to make fast decisions. So inference at the edge is definitely an interesting element of what's going on in the building AI solutions. One that really caught my eye was GROOT, or GR00T, to avoid patent issues,
I
which
am
is a
Groot.
Iron GROOT, which is a framework for having a humanoid AI. And this is the sort of bringing together of a couple of elements of the actual human-shaped things, bipedal robots that we've seen around for a while, but the need for a heck of a lot of processing to be done on those humanoid robots, and that they need to move to being a much more general-purpose solution rather than being, can we get a bipedal robot to open a door and carry a hammer into a building. Those kinds of challenges that have been the mainstay of sort of the competitive building of bipedal robots. I'm really interested to see how this framework, and we've got to find some other way of naming it than GROOT, is going to come out into fruition and turn up. There's definitely some interesting blueprints around this. Isaac is the first blueprint, the first group blueprint that is out. And it's an open humanoid foundation model. So it'll be interesting to see how this all plays out. I am still waiting for my robot butler. I would definitely like somebody to be doing the day-to-day household tasks that is not me, so I can focus on more creative things. Stephen, is your robot butler serving well for you at the moment?
Oh yeah, actually, I just sent him out in the micro fusion powered flying car to do some errands for me. Uh, you know, NVIDIA is strong with the code word names. So we've got Isaac, which is based on the Newton physics model. We've got the next generation, Grace Hopper. You had the Grace chip, you had the Hopper chip. They combined to make Grace Hopper. We've got Vera Rubin. She discovered black holes. That's pretty awesome. So we've got Vera is the next generation ARM chip coming out of NVIDIA. It's their own homegrown core, which is fun. Just like Apple, they're creating their own CPU architecture, or not architecture fundamentally, but their own CPU implementation of the ARM instruction set. And seems a direction that a lot of companies are heading in to make make a server chip of their own. And then we've got Rubin, which is sort of the successor to the next the Hopper GPU architecture. And so combine those, you got Vera Rubin. Maybe you discover some black holes using your AI infrastructure. They've also announced the next generation beyond Vera Rubin. Did you hear this? It's surely you're joking. Did you hear it? It's Richard Feynman. By the way, if you're listening to this and you're saying, "Who the heck is that?" You owe it to yourself to go get more Feynman in your life. And if you know Feynman, then you know that I'm right. Um, it's interesting that essentially Nvidia is advancing everything, doubling everything. We've got the Blackwell Ultra, which is basically twice everything. We've got Nvidia embracing joining chips together, or joining uh, wafers together to make or dies together to make a single processor. So going forward, it's not going to be completely separate chips. They're going to be really kind of closely coupled together. We've got a whole bunch of positive technology advancements on the hardware side. We've also got some great software stuff. I'm not sure if Al, if you had a chance to look into some of the VMware of AI that NVIDIA is putting together here, with their own software platform to run applications on. Uh, Ultimately, though, whenever I see Jensen Huang's keynotes, the one thing that strikes me is that, I know, shocker, this guy really seems to know the market. He really seems to understand what's going on here. And he always gives me a new way to think about things. And so at CES, it was talking about basically moving beyond LLMs to having AI systems that understand the real world and can interact and exist in the real world. And that's one of the prerequisites for this Newton physics model that underpins these robots. He expounded upon that in the keynote in a way I really enjoyed, talking about the ways in which the advancements like DeepSeek with LLM, that's not reducing the need for AI, for NVIDIA AI hardware. It's enabling us to go to the next level with entirely new models that are going to be much more efficient on sort of a per operation basis. But that means that we can use them to do more, because that's one of those laws of computing, right? The more power you have, the more ability you have to use that power. DeepSeek just allows us to do a heck of a lot more and still continue to deploy more and more. And so I do expect that there's going to be new AI models that will be doing things we never thought possible, just like today's LLMs are doing things we didn't think possible. And again, that's kind of where Jensen Huang is talking about during the keynote, is that essentially we need to move beyond LLMs. We need 100 times more power than we currently do in order to make even more amazing advances in AI. And that's what NVIDIA is working on. That's what the entire industry is working on. And that's why things are still going up and to the right in the AI space. Of course, power, cooling, manufacturing, impact on society. All of these things are some of the downsides and some of the things we're going to need to think about. I guess, Al, what are your final thoughts on GTC?
Well, in terms of that power, I liked the discussion around the Spectrum X silicon photonics Ethernet switch. This is partly also great to see more commitment to Ethernet from NVIDIA, not just everything should be InfiniBand because we own it. This is talking about having a 3.5 times energy savings. And we've previously in AI Field Day events, we've talked about what a huge amount of power is consumed simply by the optics that are transmitting all of the data inside these AI computers. And so moving towards the silicon photonics and a reduced need for those power-hungry transceivers should be a really good thing. The other element you touched on was the NVIDIA Dynamo, which Jensen talked about as being the operating system for an AI factory. And returning to the theme of agentic AI being used to operate it, Dynamo itself, the operating system for your AI factory, is going to be using AI to operate itself, because operating this factory is so incredibly complex. And this is why I think it's taken quite a while for the concept of the AI factory to turn into products. There are just so many moving parts. So yes, lots of things moving, lots of innovation going on. definitely lots of work on pain points, both for the ability to scale. Talking about Jensen's example was doing a seating plan at a wedding, very topical. My daughter's getting married next month. Being being able to do this through AI which requires huge amounts more context, knowing the people, knowing that you can't put these two people at the same table, even though they've got the same last name, because they're divorced. And acrimoniously divorced. So that kind of intelligence is going to require more resource, and efficiently delivering it is going to be absolutely vital. But the final thought has to be yours, Stephen. What was your single biggest thought about GTC and what we've seen in the keynote today?
Well, I'm going to say that the biggest thing I think is this whole idea of bringing AI into the real world, whether it's through robotics or through manufacturing or through, autonomous flying cars. Bringing AI into the real world is going to be the next challenge. We have only just scratched the surface of what all of this can do with these large language models. And next year, mark my words, we're going to be seeing some absolutely incredible advancements that are not just chatbots. We're going to start seeing AI models that really do understand the real world. And I'm excited to see where that goes.